Chemical elements in space bring us all the way back to the Big Bang. But what were the first elements made of, and how were they created? In fact, only a few minutes after the Big Bang that created the universe was a hot and dense bubble of plasma. It was rapidly expanding and cooling off at the same time. And when a certain temperature was reached in this plasma, the protons and the neutrons that were swimming around inside of it, they were merged, collided into forming heavier nuclei, like helium and a tiny bit of lithium, like the lithium that is powering my cell phone battery today. And that's how we got our three lightest elements, the lithium and the helium and the hydrogen. They were forged in the Big Bang, long before any stars or galaxies were born. And if I used more of these toys here, I could build up even more complex nuclei. But their production sites are very different. All chemical elements are synthesized inside stars. Here on Earth, we can create and destroy elements, but not without considerable effort. In particle accelerators like CERN, for example, they can propel nuclei to very high velocities and smash them together to merge them into heavy nuclei. And this process is what we call thermonuclear fusion. And this is exactly what is going on inside stars as well. To create heavy elements, like the carbon in our bodies, the iron in our blood, and the oxygen that we breathe, it requires very special physical conditions. And the reason for this is simple. When atomic nuclei have a positive charge, so when they come close together, they repel one another, like the same poles of magnets do. So to overcome this force, we need loads of them, packed into a small environment so that they frequently collide, like in a stellar interior. Stars that are more massive than the Sun, they live very short lives, but during this life, they create all the elements up to iron in their cores. Eventually, however, they will run out of fuel, which means that they'll stop producing heavier elements inside the cores, and they will stop feeding on the energy produced by this process. And when this happens, the star will fall back onto itself and explode in an event called a supernova. And in fact, this is the most common way to create elements that are even heavier than iron, like gold or silver. There are two more ways to create elements, such as gold and silver. In the first case, gas is being flung onto the core of a dead star, and this object is 100,000 times denser than the Earth. So the effect is like pouring water onto burning oil. It triggers a massive explosion, another supernova. In the third event, two such objects, dead stars, merge together after having circulated one another throughout their whole lifetimes. You can remember it by picturing my cell phone merging with another one and creating this golden one. So, the more time that goes on after the Big Bang, the more stars form, evolve, and die. And the more the cosmos is enriched with heavy elements. And eventually there are enough to form planets like the Earth and human beings. And then you might ask, is it still possible to find unknown elements? And what properties would they have? And the answer is that the only elements that we don't know if they exist today are very heavy ones, consisting of hundreds of these neutrons and protons. And maybe someday we can create them in the laboratory on Earth, but then only for a very short moment before they decay again. So these extremely heavy elements would only be alive for a fraction of a second. Sorry, excuse me. Yes? Okay, yes, I'm coming.